Differentiating trig functions from first principles is what you are going to see. Please don't forget to subscribe to the channel. Now, differentiating in first principles, you can either use the function notation or use the small changes in x and y as you are going to see. Now here, I'm going to use the idea of small changes. Now, I'm going to handle this. You use the idea to handle these two also. Now here, the idea, before you differentiate from first principles, these trig functions, you need to know the idea of factor formula. We have covered factor formula in trig lessons. You can check there and see how we use factor formula. You know that sine of A minus sine B is equal to 2. You subtract the two angles, you divide them by 2. Then of course you add these two angles if you are subtracting sine. So that in radians are very small angles. So as radian and these small angles turn into 0, when it's so small, it means that sine of this small angle will approximate this small angle. So sine of that small, you try sine of 0.001. You start will be getting the answer close to 0.001. So whenever the angle is very small, it's going to be approximating to that sine. So here what I'm going to do now, I'm going to do small changes. It said let y be sin 2x and delta y delta x be small changes in x and y respectively. Why? Because when y changes, it means that also x is going to change, because y is varying with x as you see from that equation. So if you receive a small change in y, you also receive a small change in x as you're going to see. So if y receives a small change in y, it means that now also x is going to receive a small change. So this will be now sine of 2 into it's x that is receiving a small change. So we have x plus a small change in x, which is delta x. From there, what you do, make delta y the something to take this to the other side. From here now, our delta y will be equal to sine. Now from here, we can open in brackets, this times this, we get 2x plus this times this, 2 delta x, then minus. When I take y this side, I have it like that. But I know what my y is from here. My y is this. So now my delta y is going to be then minus my y, which is sine 2x. Now from here, so we have sine, we are subtracting sine. So we use this idea of factor formula. So now my delta y is going to be, so from here, our a is this, the all of this, the angle, this is the angle now, and our b is 2x. So we say, we get 2 sine, we subtract the two angles, so I have 2, now sine, I subtract this angle from this, so the whole angle here is, then minus this angle, then I divide this by 2. Then I get cos, then I add these angles. This is our A, this is our B. So this will be now cos of this angle 2 delta x, then plus this angle 2x, now over 2. So now we start this 2x and this, they cancel. So to divide by this, we shall be adding there now as delta y equal to 2 sine now. We are making it 2 delta x over 2 cos this and this they vanish. Then we have cos of now this and this, we get 4x, then plus 2 delta x the whole over 2. Then you see that this one cancels, so we have delta y equal to 2 sine delta x, these two vanishes. Then cos of 4x divided by 2, we get 2x plus this divided by this, we get delta x. Now to warn you, this fraction, I mean this denominator is dividing this and dividing this. Don't ever, some people already divide this, no. Divide this and also divide this. That's why when I divide it here, I get 2x. When I divide it here, I get delta x. Now after this step, we now bring in the idea that in radians, in radians, comma, as delta x tends to 0, this one means tends to 0, it means that now our sine of delta x will approximate that angle, that small angle from here up to there. So that's why from here I'm going to be having now delta y equaling 2. Now this one in radians is going to be now 2. Now where is this? I'm having it as delta x from here. Then cos of 2x plus delta x. Now here, this one is not a small angle. Why? Because we have something big plus something small, we get something big. If you have a million and you add there 1,000, you get 1,000,000 and 1,000. So it remains big, something big. So that's why this one is not small angle, but this one is just something small. That's why this one for it is not tending to anything, because it's something big. So if I divide through by delta x, so delta y, delta x will be 2 cos 2x plus delta x. Now here we know that as delta x tends to 0, if it's so small, it means that now the limit of delta x, delta y, delta x, as delta x tends to 0, will be equal to a full derivative. So this in derivations of the function exponent, whenever these are very small, it means that we shall be getting a full derivative of this. So what does it mean? So from here, if I introduce this both sides, I have now limit as delta x tends to 0 of delta y, delta x equaling 2, and the limit as delta x tends to 0 of cos 2x plus delta x. So now, so this one is equal to this. Now, when I put delta x here, I'll be having now cos of 2. I have this 2 out. 2, this 2 from here. So 2, then cos 2x plus delta x. Now this delta x, we are saying that the whole of this is now at 0. So that's what I'm saying there. So now, where we put it, when we put that side where we have delta x, if we replace it now at 0, then the whole of this becomes a full derivative. And so now our the x, what was our y? Our y was a negative, we remove it because it wasn't there. So it was sine 2x equaling to now 2 cos 2x. This means that whenever I differentiate sine 2x, we get 2 cos 2x as we saw. So that's it, members. I think you can now try this one. These ones are going to give you half angles as we're going to when you're trying. The same idea is what you use. Now if we have sine delta x over 2, it means it's going to approximate to delta x over 2. That's it, members. I wish you well.